All right, Megan, unfortunately I didn't bring my iPad with me today, so I have to do this on my computer with typing, so we'll see how it goes. All right, so this is number 29 out of 1.4. We have dy over y squared equals dx. We integrate both sides. We have negative 1 y to the negative 1 equals x plus c. What I would do next is I would multiply both sides by negative 1. So I would have y to the negative 1 equals negative x plus c. And I wouldn't, you're going to see here in a minute what's going to happen here. Raise both sides to the negative 1 power. I would have y equals 1 over negative x plus c. And then to put it in the form that the back of the book has, I would multiply top and bottom by negative 1. So I would have negative 1, oops, wrong buttons, negative 1 over x minus c, which personally I disagree with. I would write it as x plus c. Back here, when I multiplied both sides by negative 1, a constant times negative 1 is still just a constant. It's still just a number. So if you have negative 1 over x plus c, that's just as good as far as I'm concerned. I don't know why they changed the sign here, but they didn't up here. Doesn't make sense to me. All right, number 45. We have di dx equals negative 1.4i. Separate the variables and solve, and I'm going to skip that. I'm guessing you can do that part. You got I equals c times e raised to the negative 1.4x. However, that c is your starting intensity, because if you plug x equals 0 in, I would be your starting intensity. So I'm going to write that as I0 e to the negative 1.4x. All right, and so then the question is, when will, for part I, when will the intensity be half of intensity at the surface? I don't know what my I0 is, but it turns out it doesn't matter, because I'm just going to have half of whatever my starting intensity is equals e raised to the negative 1.4x. And then in order to solve, oops, I forgot my I sub 0. I sub 0. In order to solve, I'm going to divide both sides by this I sub 0. So that's going to go away, and we'll just solve. Part B, part C work pretty much the same way. The value of that I sub 0 really doesn't matter. And that tends to bother students, that they don't know what that one is. All right, number 48. This is the hard one. All right, so starting with the uranium-238, we would have our formula P equals P sub 0 e to the KT. We plug in the fact that 4.51 times 10 to the 9 years is the half-life, which means we're going to have half of whatever our starting amount was. And again, we don't know what our starting amount was. Turns out it doesn't matter. E raised to the K times, what was it again, 4.51 times 10 to the 9. So again, in order to solve this equation, we divide by that P0, that's going to cancel out. We do ln on both sides, we solve. I got K to equal negative 1.54 times, where'd my times go? There it is, times 10 to the negative 10. All right, then I need to do the same thing, but I need to use the uranium, keep hitting the wrong button there, 235. Okay, so I'm going to have Q, use a different letter than P, Q equals Q sub 0 E to the negative, and I don't want to use K again, so I'll use J, I guess, JT. Now, an important fact is that they told us that the amount of uranium-238 and the amount of uranium-235 at the beginning were exactly the same, which means this Q0 number is exactly the same as this P0 number. So instead of using Q0, I'm going to use P0, which means my half-life, I'm going to have 1/2 P0 equals P0 e to the JT. Once again, except my T, I'm going to plug in my T, my half-life. It was 7.8, 7.1, I mean, times 10 to the 8. All right, so same deal. I divide by that P0. I use logarithms. I solve. I got J to be negative 9.76 times 10 to the negative 10. All right, so now to solve, how old is the universe today? I'm going to take my formula for uranium-238, which was P0 E raised to the, my half-life, my K value was this, T, and then I'm going to divide by my Q0, or my Q function, but my Q function also has P0. The only thing that changes is the J number instead of the K number. Copy and paste there, save myself a little time. And I wrote it as a fraction because it told us the ratio of uranium-238 to uranium-235 today is 137.7 to 1. So here's the ratio of the uraniums as a formula, and here's the ratio as just a number. All right, so to solve, notice these P0s cancel out, and then we're dividing two things with the same base so we can subtract the exponents. When you subtract the exponents, I got e to the 8.22 times 10 to the negative 10. Equals 137.7. I did ln's on both sides, and I divided, and I got t to be about 6 billion. I got like 5.9 something. Let's call it 6 billion years. Right? Like I said, that was the hardest one of the whole group. And finally, out of the next section, number, I forget which number it was, number 25. I think you made an arithmetic mistake on this one. You have x squared plus 1y prime plus 3x cubed y equals 6x e raised to the negative 3/2 x squared. All right, so we divide. We have y prime equals, y prime plus 3x cubed divided by x squared plus 1. Wow, this would be so much easier on an iPad. Typing math is no fun at all. Equals this divided by x squared plus 1. Now, what you have to do for this, for integrating, for finding your row, you have to integrate this. To integrate it, notice that the power on top is bigger than the power on bottom. So you actually have to do a long division. And unfortunately, I'm not sure how I'm going to show long division by typing. Give me a second here. Alright, I'm back. I'm not going to type it. I'm going to do it this way. So excuse how bad this looks. Writing with a mouse isn't easy. So I got to do the long division. So I need a 3x here, because 3x times x squared gives me the 3x cubed. And then I would have plus 3x. And then remember the way long division works, you then have to subtract. So I'm going to have 3x cubed minus 3x cubed, that's 0. Then I'm going to have 0 minus 3x, that's minus 3x. So there's my remainder. So what happens is 3x cubed divided by x squared plus 1 is the same as 3x minus 3x over x squared plus 1. And then this piece over here is a u substitution problem. U is the bottom. The u doesn't quite match, but it'll be close enough. All right. Kind of a long video, up to about 12 minutes. Hope this all helped. If not, ask me some questions in class today. See you in class.